This is Module 7 and Investigation 6, transformation of the sine and cosine function. So in this investigation, I will cover number 4 and then 5 and 6 in here. Alright, so let's take a look at the number 4. Okay, let me clear the pages. Okay, so number 4. The function is defined by h of theta equal to sine 4 theta plus 2. So where theta is an angle measure in a radian. So complete the table value first, okay? So h of theta, which is gonna be, it's gonna be the sine of 4 theta. This is where you're gonna plug it in, plus 2. Okay, so when you have a 0, right? So theta is a 0, so this is a 0. So 4 times 0 is a 0. So sine 0 is a 0, plus 2 is a 2. And then now you plug it in the pi over 8. So 4 times pi over 8 is the same as pi over 2. So sine pi over 2 is a 1. So 1 plus 2 is a 3. So if you do that and then do the same way, you got 2, 1, and 2, 3, and 2. Okay, so those are the values. All right, graph the h function. Be sure to label your axis, okay? So on the horizontal axis, I put the data, and then I put the h of data right here, which is a vertical distance, okay? So I'm gonna starting from the 0, and then every 2, I wanna make the label for the every 2 as pi over 8, pi over 4, 3 pi over 8, 4 pi over 8, which is pi over 2, 5 pi over 8, and then 6 pi over 8, which is 3 pi over 4, and then get 2 more, which is 7 pi over 8, and then up to the pi. And then the largest number we can get is a 2, right? So there's a 1 and 2 and 3. I think that'll be enough. So when x equal to 0, it's going to be a 2. X equal to pi over 8, it's going to be a 3. X equal to the theta equal to pi over 4, which is 2. And then 3 pi over 8 is a 1. And then go back to 2 for the next, and then go back to 3. And then go back to the 2. And then go back to the 1, and then dash, then do it again as a 2. So you get the curve. It's a curve, okay? Don't make the sharp turns. Alright, so here we go. That's what it is. And then see, what is the period of the h function? And then what is the period of the h of the represents here? So period means, which is sine functions are repeated functions. So which is sine functions is going to be up to all the way to here, okay? Then from here, it repeats again. And then here it repeats again. Right? So which means the first of the revolution, one revolution, this is a period. So this one is up to pi over 2. So this one is the p is the pi over 2, which is the p is a period, okay? And then what is the amplitude? So which is if you put at the middle line, okay? And then you need to from the middle line how high it goes up and then how low it goes, okay? So those are distances we call the amplitude. So it's gonna be 1 unit, right? So amplitude is the 1 for this case. All right, number 5. A water wheel used for power in the 18th century is illustrated to the right. Sketch a graph of the height of the bucket above the water in feet as the function of the angle rotation measured in radian of the bucket from the 3 o'clock position. Label your axis. Okay, so the bucket starting from the 3 o'clock positions and then turn into the counterclockwise positions. All right, so in here, this time I want to, instead of the angles, I want to put down as the angle as numbers here, okay? So if I put it as a label for 1, 2, 3, 4, every 4 I want to put 2. 1, 2, 3, 4, 4. 1, 2, 3, 4, 6. 1, 2, 3, 4, 8, and 1, 2, 3, 4, 10, 1, 2, 3, 4, 12, 1, 2, 3, 4, and oh, here, it's a 14. And then actually the highest place you can get is this is the 11, right? So 11, which is 22, and then plus 2 is a 22. So we can go up to 22. So I want to make each one is a 3. So 3, 6, 9, 12, 15, 18, 21, and 24. So 3, 6, 9, 12, 15, 18, 21, and 24. Okay, so I think that'll be enough. All right, so now the angle, right? So in here, so this is gonna be the angle, and then this is gonna be the height of the bucket. Okay, well, I put the 2, 4, 6, 8, 10 in here, but I think that better put as a, yeah, sorry. I think I want to put that as a, actually the angle here. So I want to put that as a pi over 2, and then pi, and then 3 pi over 2, and then 2 pi, and then the 5 pi over 2, 3 pi, and then 7 pi over 2, and then maybe a 4 pi here. Okay, I think that sounds better. So the bucket was actually the starting from the 3 o'clock positions, right? So height from here, so this is a 11 plus 2 is a 13, right? So 0 angle, which becomes the 12 plus 2 is 13, right? So 13 is about here. Okay. And then the pi over 2, which is the highest place, is 24. And then the pi in here go back to the 13. And then 2 pi 3 is only the 2 feet away here. And then 2 pi go back to the 0, which is 13. And then the pi over 4 go back to the 24. And then 3 pi go back to the 13. And 7 pi over 2 is now at the bottom, so which is 2 feet away from the ground. And then 4 pi will be the 13. Okay, so if you put it in, so this kind of graph you'll see. Okay. All right, so define a function f that represents the bucket distance d above the water in feet as a function of the angle of the rotation. Measure in radian of the bucket from the 3 o'clock position. Be sure to define the function. So I want to say function f theta, which is the amplitude is from the middle line, okay? So when you get the middle line, this from here is going to be 24 minus 13, so which is 11. So that's amplitude. So this is 11 feet away, right? So 11 of the sine theta, and then the middle line start from the 13. So this is what it is. And then C, define the function G, represent the bucket distance D above the water as a function of the number of the feet bucket has rotated counterclockwise from the 3 o'clock positions. So this time, I want to say G of n, which is n represent the number of the feet the bucket has traveled along the arc formed by its path as it rotates. So seems stay the same as 11, but sine, but instead of the theta, and then the number of the feet the bucket above traveling along with it. So theta is actually the same as S over R. So S is actually we call as n numbers, okay? And the R is the 11, right? Which is that's the radius of the circle. So instead of the theta, you put the n over 11, and then plus 13. So that's the function G for this case. And then we'll do number 6. So in number 6, graph the function h is given. So the first one, what is approximate the value of the period of the h? Okay, so when you take a look, So this looks like a sine function to me too. So sine of down, long down, and then up here. So I think this is the first period. And then you get again to the second period, another one, and then third revolution, right? So up to here. So up to here is a little bit more than 2. So it's about 2.1. So if you use a pi in the term, so it's about 2 pi over 3. Okay, and then what is the amplitude? So from the middle line, right? So how high it goes up? Okay, so I want to say this is about the 2.5. Okay, so amplitude is 2.5. Then define the formula could be represent the function of h. So h of x, amplitude 2.5 with the sine functions, and then the period is 2 pi over 3, which is if you have y equal to the a represent the amplitude, the sine of b x plus c. So b is coming from the period. So period is always 2 pi over b. So this period is actually the 2 pi over 3 equal to 2 pi over b. And so for b, so 2 pi b is same as 6 pi. And divide by 2 pi both sides. B is equal to 3. So it's going to be the 3x. So that's the function for this graph. Okay, thank you for listening.